Okay, so here's the last one. A university student center finds that it sells 1,600 cups of coffee if the price is $2.40. A market survey shows that for every nickel increase in a reduction in price, they'll sell 50 more cups of coffee. So that makes sense, right? You might figure out that, we know that the lower the price, the more you're going to sell. So at some point, there's going to be a point where you've reached the sweet spot and you have max. So how much should the student center charge for a cup of coffee to maximize revenue? Okay, so let's just start here. We know we're trying to maximize revenue. So let's look at what information we're given. And this is a particular type of problem that you're going to see. You've got a couple on your homework assignment for next time. So what do we know? We know that we kind of have some price demand information. We know that we sell 1,600 cups when the price is $2.40. And what else do we know? We know that if it goes down 0.05, it's going to go down 50. So if it goes down 0.1, if it goes down a dime, it'll go down up. It'll go up 100. Right? That makes sense, right? The price goes down, demand goes up. So how we need to somehow, we know that R is X times P. So we know, initially, we know what our current revenue is, 1,600 times 240. We know that. So the question is, how do we handle this changing price? And so here we're going to use X as a different, I know I've written X like this, but I'm going to, I need another variable. I'm going to call it Y. So here, I can look at it this way. If I subtract off a nickel, or 2 nickels, or 3 nickels, or 4 nickels, right? I'm subtracting off a nickel at a time. I know if I subtract off a nickel at a time, the demand will go up by that same amount. I mean, based on how many nickels. So if I go up 1 nickel, I go down 1 nickel, I go up 50 cups of coffee. If Y is 2 and I go down a whole dime, I'm going to go up 150 for every nickel. So that so for each nickel decrease is going to give me a 50 cup increase. This part is the important part. Each part, that's what tells me I have a variable there. Does that make sense? Once you kind of figure out how this pattern goes, then it's a little bit more obvious. But so the idea is I know currently what I'm selling and for what price, so I know the revenue. But I know that if I decrease it by a nickel, for each nickel, so it depends how many nickels I decrease it, for each nickel, I'm going to increase by 50. So now, what do I have? An expression for X, the demand, and an expression for P, the price. If I multiply them together, what do I get? Revenue. All right, so that means I can write revenue this way, 1,600 plus 50Y times 240 minus 0.05Y. And this is what I'm looking to maximize. Do I need any other information? And by that I mean, am I okay with variables? Do I have too many variables? No, I've got one variable, so I'm ready to go. Is this something I can take the derivative of? Looks pretty simple. There are 2 ways to handle this one. What are the 2 ways? Product rule. I can say it's this quantity times that quantity. That tells you product rule. Or multiply it out and, yeah. Yes?
Wouldn't you find the zeros first before you move on? Or is that not really necessary just because you're looking for the maximum?
Yeah, not really. I mean, yes, at some point, like I know that Y, if I'm looking at this, there is one limit that I know I have.
Yeah.
I can't have a negative price, so I know there's going to be a lower limit to how many nickels I can subtract from the price, right? I'm not giving the coffee away. So I am going to have a lower limit here.
Right.
Yeah, and so you could find that. You could say, I know from this that my lower limit, I know that, and you can write it this way. I need that to be greater than or equal to 0.
Right, but you also know it can't be more than, Y can't be more than negative 32.
Yes, but we're not,
Because then
yes,
that would make
yes, right.
you demand
Right.
nothing.
Right. So let's concentrate on how to finish it from here, but yes, those are valid points that you can put on, your limits on your, yes, on your endpoints. So let's look at this. So 4 we don't need to do. We already have it simplified, so now we need to do the derivative. Which do you prefer? Should we review product rule just for kicks? Yeah, just for fun. I know you may not want to do it that way, but let's just do it that way. So the first times what? Derivative of the second, so just negative 0.05. Plus the second times derivative of the first, which is 50. Negative 0.05 times 1600 is negative 80.
16 times 5.
Is that right?
Yeah.
Negative 80, and then minus 2.5 y, I think. 120 minus 2.5 y. 50 times 0.05, is that 2.5?
50 times what?
0.05?
Yes.
Yes. Okay,
Yes.
so altogether I get 40 minus 5y. Is that right?
Sure.
Okay. So y is 8. Yeah. So I also know that, so y is 8. So if I put in, say, 7, I'll get a positive and a negative. So I know that I go up and I go down. So what happens at 8? Max.
Max.
So y equals 8 gives me a max. Max what?
Max revenue.
Max revenue. So what am I trying to report? I need to know what price to set. So is y a price? No, what was y? Y was the number of nickels decrease in price. So I can come right back up here, and here's my price equation. If I put y equals 8 in there, I'll get my price is equal to 240, yep, minus 0.05 times 8, $2. So this says if I knock my price down to $2, I sell enough more cups of coffee that I max my revenue.
I don't believe that. I think it should be 199.
Okay, probably so, right? We all like 199, feels like we're getting a great deal. So this comes from up here. So here's my price column. Price is 240 minus 0.05 times however many nickels I'm going to knock it down. Y is the number of nickels. The number of price increments is another way to think of it. Okay,